Okay, hi, my name is Ash Perez, and this is going to be part 2 of this project. So we're going to go ahead and get right into it because I don't have a lot of time. Cool, now let's go to geometry. Once again, make this 2D, and then get whatever geometry CAD you like. And it's going to take a century to open. No, this one's actually faster. Okay, so now let's go to part 2 geometry. So we have a bunker, or maybe it was a hangar, I forget, semicircle on the ground. So we're going to go ahead and start by sketching an arc. And I'm going to put this center right there, there. Look at that, beautiful. Then we're going to make lines. We're going to keep these horizontal. And then as long as it's saying that's not vertical, but it'll lock it into vertical. And then horizontal, and then vertical, and then horizontal. Oh, there. Cool. Now that's going to be our bunker sitting on the ground, or hangar, and then all the air above it, basically. So we need to get some dimensions in here. So we can do this one, this one, this one, and radius. Cool. So let's make each two. I believe I did 400 meters, and I think for for V1 I did 150 maybe. And then for radius, you're gonna make that 10 meters. And if you have a 10-meter radius and 400 meters, then you need to be at 190 at that distance to get it perfectly centered. And wow, look at that, beautiful. Cool, now we're going to do same process, concept, surface from sketches, boom, 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 and generate. Cool, look at that, wow, it's a surface. File, and make sure you save your project. And then get out of here. So the mesh is actually pretty much the exact same process, so I'm just going to go to my mesh I already made and then go over it, but you get the idea from the last one. Oh my gosh, it takes forever. Alright, so excuse me, sorry. Okay, so I have name section here, inlet, outlet, sim, and then the cylinder wall. For my mesh, I had inflation just as before, and that inflation was near the cylinder wall here. I had triangles method. I had edge sizing near the cylinder wall as very small. Edge sizing 2, which is the rest of the edges, as slightly less small. And then that's how you get that geometry. You're going to generate, update, and save. Cool. Now, setup. Okay, so this is just for the turbulent one. So you can edit from setup. I don't know what that was about. Okay, cool. Here's your mesh, here's your inlet, here's your outlet. Remember, we got to go to models. Okay, so this is, once again, a turbulent model, so K epsilon is going to be pretty important here. You want to do the same setup, basically, it'll be fine. Okay. And then we're going to do, make sure your material is the correct defined air for the problem, so that's important. You want to do your boundary condition. In this case, our inlet velocity was 50 meters per second. Alright, and then you can just check everything from the inlet. Look at that, 1.2, 50 meters per second, 1.8, -5, and then, yep, cool. Then report definitions, force report. I don't know why that's the only one in here, because there should be more, but oh well. Okay, so we're going to do force report, and you're going to do initialization. You're going to do hybrid initialization. You're going to go to, what's it called? Run calculation, and you're going to run it. And it's going to take a long time. Okay, so now what do we need from this? We need the velocity pressure contours that we did that in the other solution section. We need the pressure coefficients and velocity distribution over the surface. So that's what I have plotted here. Or I did. I don't know why it's deleting my plots. But whatever, I guess that's for the best. Look, so we go to XY plot. Unavailable. Okay. My answers is being silly. Okay, so just so you know, the only difference between turbulent and inviscid is the model selection in the beginning. So for some reason this one's messing up now. So I'm just gonna go do the setup for inviscid. Why did it? Ah, that's right, because I opened it from the wrong place, so I got all confused. Okay, so you want to check your materials, blah, blah, blah. Okay, in model, actually, let's open up this one since I already messed it up. Sorry, bear with me. Yeah, I got it. So if I was doing my inviscid calculations here, I would select, why can I not see anything anymore? That stinks. Oh, okay, there we go. Model, I'm going to go to viscous model, and then I'm going to change it to inviscid, and that's done. That's all you got to do. And then you run it the same way as the other one. Get out of here. Give me my solution. Okay, and then this one's not messed up, so it still has my plots here. So you can plot your velocity distribution. You're going to go here, velocity, instead of what we did before was something. I forget. Yeah, you're going to go to velocity on the y-axis function, velocity magnitude, plot. Oh, you want to select your cylinder wall. Sorry about that. And it should look like this because that's inviscid flow, so you don't have the no slip condition. On your inviscid, on your viscous one, you will have just a velocity that's just flat 0 because there is no velocity on the surface. Don't panic. And then same deal here. Pressure, pressure coefficient, cylinder wall, say plot. And look at that, nice and pretty. As inviscid always should be. Okay, and then you can go to your report definitions and do your drag coefficient and lift coefficient the same way as you do on a flat plate. Well, lift coefficient you didn't do on a flat plate, but it's the same way as the drag coefficient. You just go into force report, and then there's going to be a lift drop down, and then lift coefficient. Problem solved. Cool. Okay. And then results. So this is where you're going to do your post stuff for your pressure coefficients and, contours and velocity contours. Yellow. You can do it. Okay. Pressure contour. Look at that. Amazing. Stagnation point. You're going to have your lowest pressure here because you're going to be moving the fastest. And then you have your second stagnation point, which doesn't make any sense in normal life, but that's how it works for inviscid flow. Check our velocity contour. Look at that. Low velocity here, high velocity here, low velocity there. As you expect, pressure should be inversely related with velocity. Cool. That's done and done. And remember, just to do that, you got to go up here to contour and then just define what you want to do. Same way as the previous part. Let's see if my turbulent ones are still here. and they didn't get destroyed because I like the way they look. Wow, it's taking its sweet time. Okay, cool. So pressure contour is nothing amazing here. I did have to adjust the bounds here a bit. So you see your stagnation point. You don't see a second stagnation point because that doesn't make any sense. Once again, you're speeding up here, so you're going to have a lower pressure, and then your wake region pressure is going to be lower than your pressure over here because there's not as much air getting to it, but it is going to be higher than your pressure here, which is going to cause your flow separation. So we should see a wake region right about there. And, believe it or not, look at that, wake region. So this is your velocity, stagnation points here, high velocity here, where we saw that pressure difference. You now have your low velocity because it's just kind of spinning, not going anywhere. And that's your wake region. All right, done and done. That is how you do, I believe, the whole project. I did have some meshing problems that made my thing not work so well. The easiest way to tell is to do your inviscid one first because it has to be symmetric, and it's very obvious when it's wrong. So if you have a meshing problem, it's not going to be symmetric and it's not going to look nice, and you just honestly just start over. That's what I did. I had to do it twice. It's not the end of the world. Okay, thanks for watching.